So tangent lines. A tangent line intersects a circle at exactly one point. That point where it does intersect, that is what we call point of tangency. And what's important about that is that the tangent line and either the radius or the diameter are always going to be perpendicular to each other, right? So it's always going to, the tangent line is always going to be perpendicular to either the radius or the diameter. And it's going to be perpendicular, not halfway through the diameter or through the diameter or the radius, is going to be perpendicular at the point of tangency. And one of the important things about it is that if I were to draw a segment from the center of my circle to a point out on the tangent line, then we can see that we create a right triangle. And that's important because when we work with right triangles, they allow us to solve various type of problems, right? So, for example, a right triangle, we can always use Pythagorean theorem to figure out the things that we need, right? So the A and the B, the sides, they don't really matter. What does matter is what we call C. Remember, C is what we call the hypotenuse. And if we're ever looking for C or the hypotenuse, it's always going to be A squared plus B squared. If we are either looking for either A or B, then it's always going to be C squared minus either A squared or B squared. Okay. So here's our first problem. Okay. So for this particular problem, notice how we have a right triangle already here. And we have our A and our B, and what we're looking for is our C, our hypotenuse. Right, so this is our quote-unquote C. Here's A, here's B. And so since we're looking for the hypotenuse, x, we're going to use A squared, which is 7 squared, plus B squared, which is 19 squared. And so from here, it's just a matter of simplifying each step. So 7 squared is 49. 19 squared is 361. Add those together, we get the square root of 410, which is approximately 20.25. Okay. Looking at the second problem, we're looking for x as well, but this time x is kind of over here on one of the sides. We'll call A. What we don't know is C in its entirety, because C is supposed to be this whole thing. This 7 only represents that distance there. And so one thing we have to keep in mind is that the radius inside a circle is never going to change, right? And so over here, we notice that we have a radius of 11. So that means that from here to here, that's also the radius, and that should be 11. Therefore, that entire C, the entire hypotenuse, is 11 plus 7, which is 18. Okay, and so now we have everything that we need to solve for our missing side, which we'll call A. And so here we're looking for A, so we're going to do the square root of 18 squared minus 11 squared, and we're going to simplify each time. So 18 squared and so 18 squared is 324. 11 squared is 121. Subtract them, and we're looking at the square root of 203, which is approximately, A represented x, which is approximately 14.25.